Okay, cool. Just checking the thing's working. So, hello everybody. My name is Land-Strykowski. I'm an astrophysics PhD student at the University of Sydney. And, thank you. And my subject area is cosmology. Not cosmetology, I've heard that one before, but cosmology, the study of the cosmos and the universe. And I'll be taking you through tonight of our cosmology and also some of my favorite alternative cosmologies that you may or may not have heard about. So we'll start with our own universe. We start with a Big Bang, this massive explosion at the start of the universe from a singularity that gives us all the stuff, all the mass, elements, and gas and things around. And that is what we'd call the birth. And then we move into the life phase of the universe, where we form stars, planets, galaxies, and moons, and us. And we live here in this life phase. We are living. And this is a very special part of the universe, where we can look out and we can ask the big, hairy questions. But like any organic thing, such as the universe, it has a birth, life, and potentially a death. And to understand how the universe might end, we first have to know what is inside of it. The universe is made out of three main things. We have these visible light, visible matter, which is the stuff that we can see, feel, and touch around us. That is what we're made out of. And that is the intuitive form of matter. Then we also have dark matter. This is a bit more exotic of a matter, something that we don't know as much about. We look into the universe and we can see that gravity is there in galaxies and things around us, and gravity is caused by mass. But there's a deficit. Some of it can be explained by the stars and the things that we can see, but there's this gap. And that gap we attribute to dark matter. So we're in the dark about it, and it also doesn't give off light, hence dark. But then we have this third companion, dark energy, and that's even more abstract. When we think about our models of the universe, we know there must be a certain amount of stuff inside of it, a certain amount of energy, and we contribute that to the things that we see and the things that we infer, like dark matter. But there's another gap, and we call this dark energy because we're also in the dark. And dark energy turns out to be really important. We believe that it is the driving force behind the expansion of the universe. If you have too much dark energy, the universe will expand so fast and have so much acceleration and expansion that things will start to get ripped apart due to that expansion. Galaxy clusters will be ripped apart, the galaxies inside them will be ripped apart, stars, planets, and the atoms that form us will get ripped. And we call this end of the universe a big rip, as time and space get ripped apart. That is quite a violent destruction to the end. But if you don't have enough dark energy, then gravity will take over. Dark energy is trying to push out and expand the universe, gravity is trying to pull back in. That's what tracks everything together. So without enough dark energy, everything will track together, come to a big crunch. And everything coming to one small point again sounds a little bit familiar. That sounds like a big bang. So not only could you get a big crunch, you could get a big bounce, where everything comes together again, crunch, then another big bang occurs. Then it comes together again, and it goes bounce in and out for a big bounce. But if you have the right balance of dark energy and gravity working together, which is what we believe our universe is very close to, you get a big freeze, where the universe will continue on for a very long time. It won't crunch, it won't rip, it will just survive for a long time. And eventually we can see what happens to really old things, such as stars. Stars will get old and lose all their fuel, they become dim and dark, and the universe will become a very cold place. Atoms themselves will become so close to absolute zero, they will stop moving. And that's why we call it a freeze. But this isn't all dark and gloom. If the universe is going to last for a really long time, we can do a lot of cool stuff. We can ask even bigger questions. And this is one of my favorite questions. What about a multiverse? We've talked about how our universe could survive for a long time, but that's one story. What about the alternatives? Could there be parallel universes? Could there be all these different characters that we see in science fiction? Could I go through and collect all my different variants of Carl Sagan and Stephen Hawking and put them in my pocket? Well, perhaps you could. So some theories suggest that you could have a very complicated relationship of universes and parallel universes and white holes and black holes like this. Now, there's a lot going on here, and I want to preface by saying we do not see evidence to support this, but it is a mathematical solution to Einstein's equations. We're going to focus first just on our universe. We are the yellow dot, and we're going to try and move around. The first thing you might try and do is say, well, there's a parallel universe right up there. Why don't we go and visit it? Well, there are two rules that we have to follow. If you go towards me, you're going forward in time. If you go back that way, across the horizontal, you're going backwards in time. up and down is through space. So if I'm going up without going left, then or left or right, then I've gone up in an infinite velocity. And I've done that in no time, and you're not allowed to do that. What you can do is go at 45-degree angles. That is equal to going at the speed of light, and anywhere in between that cone is less than the speed of light, and that's allowed. We call this a light cone, a future light cone. All the future places that you could be fall within that cone. The existence of a light cone that goes into the future implies a past light cone as well, where all these are the places you could have come from. And we can see here, we could have come from the white hole. Now, black holes may have heard about before. If you go past the event horizon, you can't go out again, you're kind of stuck there, and you go towards the center. With a white hole, it's the opposite. If you're within the event horizon, the only place you can go is out. A white hole is trying to spit you out, and a black hole is trying to suck you in. So, we have the option of going out into the parallel universe or into our universe, which is quite interesting. But we started in our universe, so let's try to do something exotic. Let's try go inside the black hole. Usually, that is a bit of a death sentence. You will not survive again. But if the black hole is rotating, you have 2 event horizons. And if you traverse it just perfectly, you can go through and go further. You can go through the black hole to a white hole that connects to it. And that point between the black hole and the white hole, we call a wormhole. And then, once you're at the white hole, you're left with choices once more. You can go to a new universe or a new parallel universe. So let's choose one of them. And just like that, we've traversed the multiverse into a new place, and we can keep going. If you were so inclined, you could go back into another rotating black hole in that universe and start the whole process again and discover more things. This way, you could collect all of your Carl Sagans and Stephen Hawkings. So that is where I'll leave you today. If you want to travel the multiverse, look at this.